let's talk more about points and vectors. So we already discussed that points usually define different locations. So let's say a location of this tree, where is this tree in the world? Locations of each of these leaves. We'll see later that different shapes are made out of like meshes of polygons. So the vertices of the polygons are at specific locations, so those are points. And then these vectors usually define some kind of a direction, like a wind. So wind is blowing this way. This leaf is moving that way. This leaf is moving that way. So a direction, like a movement or some kind of direction. If you are more familiar with polygons, you can also think like a triangle has this normal vector, the surface normal that is pointing in a direction perpendicular to its surface. That's also a vector, but the polygon itself is made out of points. Now, in computer graphics, there is this interesting thing called homogeneous coordinates, and it's a notation. It's a notation where we add an additional coordinate to distinguish between points and vectors. And it actually does have a very useful use, which we'll see later in the material. But right now, let's just look at the definition. So if we have a 2D point, then in homogeneous coordinates, this point P actually has 3 coordinates, x, y, and z, not just x and y. And the 2D point that it denotes is x divided by z and y divided by z. So a 2D point is represented with 3 coordinates, and it denotes a point where the coordinates, the first 2, are divided by the third one. Similarly in 3D, so a 3D point would have 4 coordinates, and it denotes a 3-dimensional vector or a point where the first 3 are divided by the fourth one. So this is all that it is. So we just add another coordinate, and it must have a specific value. And if we want to get back to our regular space, in the case of 2D, just 2 coordinates, or 3D with 3 coordinates, then we divide by the last coordinate, the first 2. Now, in these 2D homogeneous coordinates, a point that would be a location would be this triplet where the last value is not 0. So put anything but 0 there, and you will get a location. Let's say you put 1 there, then you would just have x divided by 1, y divided by 1, and it would be xy. Exactly the same xy that you have in this notation. But you could also put something like 2 there, so x divided by 2 and y divided by 2 would be the actual coordinate or actual location of that point. Now, with vectors, you put 0 there. So for vectors, it would actually end up with x divided by 0 and y divided by 0. And don't tell this to your math teacher, but we could kind of think about it like x divided by 0 would be some infinity, and y divided by 0 would be some other infinity, so it would be infinitely far away in one direction and infinitely far away in another direction. And it would kind of be a point in infinity. But if that is too weird, then you can just think about like a vector would be x, y, 0. Anything in homogeneous coordinates where the last value is 0 would be a direction. And we'll actually see another algorithm in later on in the course where this division by 0 is something we will do on the GPU, and it would give us like points that are projected to infinity. But we'll see this in the end of the course. So if you stick with us to the end, you can see how we divide by 0 on the GPU and get a meaningful result out of it. And well, of course, in 3D homogeneous coordinates, you have a fourth value there. So a point would have a w that must not be 0, and a vector would have, a 0, x, y, z, 0. Now one more thing, so very often you are supposed to define this 4-dimensional point. So you have x, y, z, and you want to make it put it into homogeneous coordinates. So, what do you put as w? Well, you put 1, because that would be x divided by 1, y divided by 1, z divided by 1, that would be x, y, z. So if you have x, y, z coordinates and you want to represent it in homogeneous notation, and it's a point, then you just put 1 as W, and there it is. And you will see this in the practice session that in the shader code, the GLSL shader code that we talked about previously in the materials, then there is this suspicious 1 at the end of a 4-dimensional vector. So this is what it's there for. It moves a 3-dimensional point into these 3D homogeneous coordinates. Now, from this video, you should now know more about points and vectors. So how do we use points in computer graphics? How do we use vectors in computer graphics? And also about homogeneous coordinates. So what are they for points? What are they for vectors? This little bit of insight that vectors are points in infinity, which we'll come back to in the end of the course, and how to convert between the homogeneous and regular coordinates.